So we'll be starting up right about 2 p.m. here. We got a few minutes left. Mm-hmm. 2 o'clock. All right. All right. So my name is Jeff Scott. We're going to be talking about preparing an asset management plan for pavements. We'll see if I can make this thing move. There we go. If you got any questions, we've disabled the chat. Raising the hand, I don't see that while I'm talking. So if you have any questions, put them into the Q&A, and if I don't see them and answer them, I'll have one of the guys behind the scenes will actually let me know. Kind of help me along here. There are professional development hours we're offering for this. One, since it's only an hour. And then only the person registered will be getting that, because that's the only way we can kind of keep track of it. Once you get your certificate of attendance, send that back to us and we'll issue your PDH. If you're from another state, check with your LTAP center and we'll work with those guys to see if we can get you those PDHs. So again, as preparing an asset management plan for your pavements. So why do we care? Well, in New York State, highway ownership of the local highways, basically 52% of the highways in New York State are locally owned. Having a good plan is pretty important. You can see here the cities have about 11%, villages 6%, counties 18%, and then the state really only has 13% of the roads. So a lot of the road network within our state are on the local roads. And why is this an issue? Well, it really comes down to funding, and that's what an asset management plan is all about. The local highway funding, basically 89% of the funding for local highways comes out of your local budget, your local tax dollars. So if we can manage them more efficiently, we're going to be a lot more successful. So we've got a series of questions. I guess I skipped the first round of questions. So we'll put the first round up. Adam, if you can put them up. These are just general questions. How many folks at your site? Where do you work? And you may have to scroll down, but how long have you been in your position? So we get about 70, 75%. We can stop that and kind of show it, and then we'll have that for our records. And then if you could, Adam, maybe pop up those next questions after we've completed this one. So I have no idea how well we're doing here as far as percentages, but. Are we close, Adam? Oh, we must be. So a lot of people singularly doing their social distancing. We got a couple with quite a few in there. A lot of town folks, that's good. A few state, a few counties, cities, villages, and then other. Great. All right, we'll close that. And Adam, can you put up the next set of questions? All right, we got a few questions here. I believe there's just 3 of them at this point. Just some general questions to get a feel of where we stand at this point. Should maintenance be done on good roads or poor roads? Do you have a plan for the next 5 years? And do you have enough funding to maintain those roads? All right. How are we doing, Adam?
We're at 54%.
All right.
Give it a few more seconds to let people vote, and then we'll post the results here.
Sure. Again, these answers are anonymous. Nobody really knows who's answering. Good, Rose. Excellent. Good. People got a plan for the next 5 years. That's very encouraging. And nobody has enough funding, and that is the trend, it seems, anymore. All right, we'll close that out, and we'll move on to the next slide here. There we are. We're back in motion. The pavement costs. Well, most of our roads over the years have basically been evolving. We've been doing maintenance and investing in them, and doing a lot of repairs and corrections and overlays, that kind of stuff. We spent a lot of money on these roads over the past years, but unfortunately, a lot of these roads are experiencing major distresses. And if these problems aren't corrected in time, the cost to bring these roads back to an acceptable condition are going to be a heck of a lot more. Often, treatments are deferred, letting those problems basically increase in severity to a point where the reconstruction is necessary. And most of you guys are probably familiar with the fact that once you reach reconstruction, it's a big dollar to fix those things. Any kind of plan like this is going to be disastrous as prices increase and the funding decreases. So typically your maintenance budget gets worse. It rarely gets better. One of the reasons that we're kind of talking about, we need to be a little bit more efficient with what we're doing and how we address these roads and how we spend our funding. Most of us are pretty familiar with this. I know the state's got one that goes a little bit different in direction, but they basically convey the same message. 75% of the life of your pavement, your roads typically go from excellent to a mid-fair point. And usually to the untrained eye, they look pretty good. But in reality, you can see there's minor cracking within it. You start to get some distresses showing up. Again, they're minor, so you don't necessarily see them. Once you reach that, and once you reach beyond that, though, those distresses start to open up. The moisture gets into your base, and those roads start to fail rapidly. So as you can see here, the rehabilitation costs are substantially less. So if we can do maintenance on those roads, we're going to be a lot more successful in keeping those roads in good shape. But if we wait till those roads deteriorate, we're going to see big dollar items where our budgets just can't support that kind of maintenance. And the maintenance, typically to keep those roads in good shape, would be the routine maintenance, preventive maintenance, and corrective maintenances. And we'll talk a little bit about each of those coming up. But then you reach those rehabilitation and reconstruction costs. Again, they become cost prohibitive, and it can really kill our budgets. So with the old adage, pay me now or pay me later, pavement maintenance is a case of penny wise and pound foolish. It doesn't make sense to save pennies now, putting off needed maintenance. Those deferred payment repairs are actually going to cost you dollars later on. A simple comparison is basically for deferred maintenance is like a debt with very high interest rates. That debt has to be paid sometime in the future. The longer you wait, the more you're going to pay. Here's an example. We've got a section of pavement built 12 years ago. It needs a surface treatment now. That'll be about $20,000 again, depending. It's going to vary depending on the road length and size of what you do. But just for this example, it's going to be about $20,000. If we defer it for 4 years, then we start to get those failures starting to show up, and then we have to rehab it. It's going to increase those costs to $60,000 to $80,000. That's a substantial increase when you limited funding. And then if we wait too long, it could be just another year or two, depending on a lot of factors. But if we wait too long, those prices could skyrocket well beyond what we're capable of affording. And those roads are typically going to end up being poor for a long time because you just can't afford to fix them a lot of times. So pavement management, essentially, it's not a new concept. Everybody has some set method of managing their maintenance on their roadways. A pavement management plan shouldn't replace current practices of an agency. Technically, they should improve them.
Hey, Jeff?
Yes.
Maybe it's the Wi-Fi you're in, but just the sound's coming in and out. So just so you know.
Yeah, I'm trying to be consistent.
Yeah, it could be the Wi-Fi. I know where you are.
All right. Payment management system is a formal maintenance program that provides a systematic, consistent approach to evaluate the present condition of each pavement surface. It determines the proper type of payment maintenance to fix the distresses, again, focusing on fixing them, and then try to prevent the acceleration of the degradation of those conditions. It should also prioritize necessary repairs within a network and produce reports. The report information should include overall condition of the network, the cost to return the entire network to an acceptable service. So again, having these structured formats is going to help us in the long run. As I mentioned, we all do some sort of pavement management. Several of pavement management practices that are out there that don't follow any kind of systematic method or even cost effective for that matter. Last year's budget, using last year's budget as with arbitrary increases and decreases. We've got the squeaky wheel where the residents are complaining and there's emergency demands, and that's all we do is just kind of run from place to place with no real plan. There's a standard program where it's an established program based on periodic maintenance, such as seal coats every 5 years or overlays every 10 years. The worst first, which is one of the worst ways to go, that's where major maintenance is prioritized on the worst first basis. The streets that look bad get the attention. It seems logical, but it's really not a correct one. Well, hopefully you'll understand that by the time we're done with this. There's always the political pressure, especially on the local level. I don't know how many times I've seen roads paved in October just before elections. That is really the wrong way of going out to it. You're just throwing things at bad, you're throwing good money at bad projects, and it turns out to be kind of a waste. And then there's the gut feeling. A lot of times the gut feeling is really the right way to go with experienced people. You're taking that knowledge and experience and then you're doing what you feel is right. Part of the problem with that is you've got no documentable evidence on why you're doing this. So it's tough to communicate, tough to justify. Oh, we got this deal. So the maintenance decision process, whether individually or combination, a lot of those other ones might work with adequate funds and a system that's satisfactory condition. But if it's in bad shape and getting worse at the same time, funding sources are becoming scarce. There's going to be a push to lower taxes, and it's going to be clear that better decision-making process is going to be necessary. Particularly in tight fiscal environments, we're going to need to ask critical questions, like how many miles do we maintain? Should we maintain the best roads or the worst roads first? What will the impact of changing funding changes, whether they're increases or decreases? What's that going to do to our management program? What are some of the more cost-effective maintenance treatments for a particular road? Every situation is going to be different. What are our maintenance rehabilitation requirements over the next 5 years? How can available money be spent the most cost-efficient way? As far as everything, it's very essential that we answer these questions. Municipalities need some sort of means of assessing the condition of the network and weighing those alternatives and establish the long-term programs for their budgets. With the decrease in available funding, it's increasingly important to take these more effective approaches. And it can be done. So the basic concept behind the pavement management program is focusing on preventive maintenance, doing those cost-effective, let's not say cheap, but cost-effective maintenance routine at a lower cost than waiting till everything fails and then spending all your money on one little project. So that's kind of the goal with that we're looking for. And then you can do that with a structured, cost-effective strategies. Some of the key elements in some of the complex pavement management systems, and they range in complexity and required knowledge, but the collection of the information, planning the maintenance strategies. What are you going to do? How much are they going to cost? Do an analysis of the data. Developing a long-term maintenance program using elaborate software programs based on deterioration curves and present condition. Then you have to design the maintenance projects. Then you got to oversee the maintenance construction projects, make sure they're done properly. Then it helps to do some research to support the pavement management system, like what is the life expectancy? What are the costs of the maintenance practices? What are new repair alternatives? If something's not working, you might want to change it up. Maybe there are other alternatives that are going to work better for you. There's also a feedback process, and that's going to help refine this system so it becomes more effective. So a lot of these softwares vary greatly in the magnitude, and they're flexible in nature, but they need to be adaptable to the needs and the availability of any agency. With a pavement management system, there's two levels. We've got a network level where you're basically looking at the entire network. You're gathering critical information, but not detailed information to analyze which projects should be funded first. The second level is essentially where you've got the project level. That's where now you've decided to do the job. You're going to look at it a lot more critically. Now, if you've got curbs, you're not going to do an overlay because eventually you'll lose your curbs. So you're going to have to do some sort of mill and fill. So you're going to have to look at these projects in more specific to make sure you can correct everything as you're going into them. The network level pavement management systems, there's several steps that need to be done. Defining limits. Some roads are miles long. Assessing a road that's miles long is going to be difficult, not to assess it, but to repair it. So we break these roads into segments, manageable segments that we can repair. Then from there, we develop a road inventory of the network of those individual segments. We do individual surveys on each of those segments. And again, windshield surveys tend to work just as well. We can develop maintenance strategies based on what we're seeing. We can determine the funding once we've developed maintenance strategies and puts price to them. We understand what we're going to need, how much we're going to need, and where we can spend it. At this point, you can interactively select and analyze different projects, determine which ones are going to be the most cost effective. Then, as I mentioned, the feedback system, you can implement that. And that's basically updating your costs, your life expectancies, and revise your maintenance practices. Again, the whole goal of this is to improve the reliability of the network system. The project level, on the other hand, is, again, that I mentioned, you're focusing on individual projects. You identified the causes of the distress. You've identified the distresses, now you want to identify the causes of these distresses. And from there, you can determine the right maintenance technique to correct each distress. And the goal, again, too, is to fix these distresses. You don't want to put a Band-Aid over it because those problems will show back up. And then you want to basically design the projects, analyze the requirements for it. So you got a correct fix. And then you want to write contract and then specifications so you get what you're expecting. So how is this done? When implementing a pavement management system, it's important to keep it basic. It's got to be easy to use, but still provide necessary information to make prudent investment decisions. Some of the criteria that need to be met or should be met, it should be easy to learn and apply because most decision makers have no formal technical training. It needs to be systematic and provide an organized approach to ensure that all contributing factors are taken into account. It needs to be practical. Taking care of your road systems is an ongoing real-life activity, and the management process must be both workable and realistic. It needs to be understandable and accepted by the local board. Being simple is going to, and systematic is going to help that be that way. Because there's no free lunches. The total commitment of the program is vital to making it work. As I mentioned, there are a number of package systems that are out there, but many of them are very complex and require the use of confusing software to handle and process. It takes training, it takes time, and sometimes takes a full-time person to do it. However, the maintenance, wow, I'm bumbling today. But the managing the road surface program is actually a simple one, and it doesn't need to overwhelm the user. Again, the idea is to fix the problem. Let the road tell you what it is. The distresses have causes. Let it tell you what it is, and then go back and try to fix the disease and not the symptoms. If you've got a crack, filling it's going to help, but it's not going to fix it. So it's a simple network process, and I'll use our CAMP software, our Cornell Asset Management Program software as an example. It's essentially just a snapshot in time. It doesn't determine what's going to happen in the future. This process, essentially, you gather an inventory, you collect your inventory, and we'll talk about that coming up. Your condition, how to evaluate that, assign repairs, and then diagnose the current status of the network itself. Look at the whole network as a whole, and then you can from there basically develop a plan based on a simple formula. And I'll show you that formula here, but I'll talk about the pieces coming up. The simple formula itself, it doesn't use actual cost comparisons. If you've got two projects and one's going to cost more, they're going to go with the cheapest one if you're dealing with the town board, trying to get the most out of their money. But that doesn't necessarily fix the project. So we don't do add cost comparisons. We want to look at the conditions, have a priority number, maybe a condition index, and then we can compare the roads based on what's important to those roads. It also basically doesn't include a future deterioration. That requires complex reiterations, a lot of thought, a lot of planning, a lot of curves, and a lot of knowledge and training. And it needs to be basically easy to modify. So your inventory development, again, you're going to take the inventory of each road segment itself. And there are data sources out there. Prior surveys are useful if you've got one. Local maps are helpful. Of course, it doesn't give you all the information. Local knowledge, that can help you on the past work that's been on those roads. And the CHIPS reports. The local highway inventory has a majority of the data that you're going to need. And it's a very good resource. You can go on there. It's all online. You can download it or just go right into it and download the PDF, and you can isolate different categories, your county, your town. It gives you a lot of information. But you got to remember, if you're going to, the information you put in there has got to be good. If it's not good, you're not going to get good results. It's the garbage in, garbage out. So keep in mind, you got to keep your information good. So some of the essential inventory information for each road segment. Again, we got to do each one. There's going to be an road identification number. The local highway inventory provides a inventory number, but it's typically for the full road. So you need to break that into sections and then identify each of those individual categories. You need to provide a physical description where that road starts, or where that road section starts, a physical description of where it ends, maybe from street to street or culvert to sign or whatever it might be. But you need some means of being able to identify it in the field, not by measuring every road section. You need the width. Again, this is going to be part of your calculations of your surface area. You need the surface type. You have a gravel road, you have a paved road, you have a brick road, you have a concrete road. That's going to be important on a lot of levels as far as determining what you're going to do with it. Obviously, you're going to want your road name to it. The shoulders, that's going to be important to know what your shoulders are. As I mentioned, if you've got curb shoulders, an overlay, multiple overlays on that are going to bury that curb in no time. So knowing what you have as far as a shoulder goes, whether it's a gravel or paved, maybe it's a paved shoulder, and when you're doing your calculations, you want to include that shoulder into your paving program. And then, of course, we need our distances. Where does that section start and where does it end? That'll give that distance times the width will give us our surface area. We'll need to know what the traffic is, and I'll touch on that coming up, and what the importance of that is to the community. The traffic itself, again, using road classifications. You can see that we got the collector, local road with trucks, road to school. These are all different levels of traffic volumes on them typically. The collector road typically has very high volumes. Again, it's collecting all those roads from the minor roads. Local roads with trucks, because of the weight of the trucks, that's going to kick it up a little higher. The road to school, that's going to be a moderate level road. Then you've got your lower ones, the residential and the seasonal roads. With the importance, again, you're using your road classifications as we go. And then the importance range, again, what's important to the community to move around. You've got your collector roads, they're going to be very high. Local roads with trucks aren't going to be as important because, again, they're local roads. They're not going to be as critical to the entire community. But the road to school is going to be much higher. and then residential and seasonal. Again, these numbers that we're seeing next to the very high, the moderate, the high, the low, the very low, these numbers are going to be used within that calculation of our formula that I will be showing you here in a little while. Traffic had those same numbers as well, and those are going to be utilized within that formula as well. The condition survey is critical to assess each condition on each road segment. That way you've got a whole view of the whole network. Because there's a direct correlation in the software that links each distress type to each maintenance repair strategy. So as you select the different types of condition, it's going to link within the software, at least in our camp software it does, and many of the others it does as well. As far as the condition survey, again, it's going to depend on the road type, the surface type. That's going to dictate what types of distresses you're going to see. But in evaluating those distresses, we try to keep it simple in these in the software. We use descriptive scales to record the severity and the extent. And severity is just how bad is it? How bad are those cracks? And extent is how often do they show up? And this way, just the simple extent and severity can be used by non-technical people, so it's a little easier to use. It doesn't require a lot of training. And these are just some of the sources that are out there as far as evaluating your roads for determining those cracks and the width of those cracks and the severity of them. The Federal Highway Administration puts out a distress identification manual. This is very useful. Pretty complex. It's got a lot of information and it goes through several different types of pavement types. We've also got our pavement maintenance manual for our workshop. Chapter 4 focuses on pavement distresses. Again, useful resources, and we do have a handout that's available that Adam will make available. And the links for those are on those, so they're accessible as well. Some of the distresses we talk about for unpaved surfaces, cross-section, roadside drainage, corrugations, potholes, rutting, loose aggregate, dust, and roughness. Again, each one is going to be assessed, and then they're going to be evaluated, and that's going to go translate into what we are going to do as far as maintenance goes. The asphalt surface distresses, longitudinal transverse cracking, alligator cracking, edge cracking, patching, potholes, rutting, bleeding, raveling, drainage, roughness. These aren't all of the distresses that are out there, but these are the ones that are the most critical, and these are the ones we kind of use in our software. Related to those, we've got repair categories within the software. One, obviously, the defer maintenance that probably used a little more than it ought to be, but maybe not enough in some cases. We've got the dust control on an unpaved road. Additional gravel, reshaping, regrading, rehabilitation. Again, you're trying to fix those problems. With the paved roads, again, we've got our defer maintenance, but we've got crack repairs, patching, surface treatment, overlays, and then, of course, the rehabilitation and reconstruction. And all those distresses are linked to these repair categories, and I'll talk about that coming up as well. But how do these repair categories work? Again, we're looking to try to maintain roads in good shape and fix them as we go. So there's the order of work basically focuses on preventive maintenance, then routine maintenance, and then corrective maintenance. And these will basically preserve the roads, seal the cracks, overlay and just basically give it a new surface, seal the conditions. If there's corrective maintenance, maybe you've got a section of road that's in poor condition. Fixing that one section will improve that entire road network system. And then, of course, we've got the defer work, which if your roads are beyond any of these maintenance techniques, maybe you just want to put it off because you're going to have to do rehabilitation or reconstruction on it eventually. Then we have our rehabilitation and reconstruction. And this is, again, this is where the costs start to skyrocket as far as making those projects work. Within the software, this is kind of the how they're linked. You can see the defer maintenance is, again, we've got the 1 through 3 in the repair or 1 through 8 in the repair categories. The crack repairs, patching, surface treatments, all those repair categories we just saw for paved surfaces. But in this case, we've also got drainage. The drainage is critical. With the maintenance strategies, the numbers on the right side of the column of this screen here, these are the ones that are used within the software. So essentially, we've got a defer maintenance. That's about the mid-range. Again, priority of work. Preventive maintenance is top, so you're going to get the number 6 on there. The higher the number as far as priority goes is really going to tell you when you need to do those roads. We've got routine maintenance, they're next, and then corrective maintenance. But notice that the drainage is right up there with the routine maintenance. Again, keeping our roads bases dry and keeping that water away from our roads is going to be critical. Then we've got the defer maintenance and then the rehabilitation, reconstruction. And those, again, as I showed earlier, those routine, preventative, corrective are still when that road's in good to fair condition and better. Again, we're looking to preserve those roads, keep them in good shape. This is some of the cost systems within the software itself. You can see on the top, we've got our surface type up here. And we've got a repair category, which we had just seen in that previous screen. We've got a repair name. And then right here, our repair cost. This can be done by square foot, square yard, square meter, whatever you're measuring your roads at. And it gives you a repair life, or basically how long that repair is going to last. So in this case, we've got a 0.068 per square foot. You multiply that by your surface area, square footage, and it'll give you a value, an estimated value. Again, it's a project, a network level estimate. Within the software itself, it gives you all these different repair types that are there. For different surface types, we've got multiple different types of surfaces within the software. We've got unpaved roads, we've got surface treated roads, we've got asphalt roads, we've got concrete roads, and then we do have a section for brick, but we haven't quite built that out yet. But you can see the repairs over on the left. You get the repair category, your surface type, and then your unit cost. Again, per square foot, this is what tells you what the units are and what the life extension is. And this will help you to decide when you're selecting repairs, what you're going to get for your buck and how long it's going to last. In this case, on that previous example behind this little screen right here, you can see the chip seal. It's a surface repair category and a surface treated road, and there's that 0.068 per square foot. And again, our life performance is estimated at 36 months. And that's going to vary depending on where you are in the actual road itself. But again, this is just kind of a representation of what we have. When you're applying your repair, you can see at the top here, you've got some of that inventory name, inventory information. You got the name of the road, where it starts, where it ends, how long it is based on that mile point start, mile point end. And then based on its width, it'll calculate up a square footage. And that square footage times that unit price is going to give you an estimated cost down below. So there's a surface treatment repair category, and there's our price to it. It looks like my letters have slipped a bit, but again, this is how it works in software, but this can all be done by hand as well. Software just makes it substantially easier. And then behind each distress that we're going to evaluate, there's a decision tree. So each distress that's, there's got to be a decision tree for each distress that's surveyed. And that's, this maintenance tree provides a link to assigning repairs, and that kind of brings it all together. And what it does is, through a deduction system, it creates, it calculates out a pavement condition index. Now, this isn't a pavement condition index you'll see used in the federal highway system. This is just a deductive value that we generate within the software itself. And this is basically when you're assessing your distresses. In this case, we're evaluating a road section here. Again, your inventory information is here. And then you've got individual distresses, as I mentioned. We got the drainage, the roughness, longitudinal transverse cracking, alligator cracking, edge cracking, and all those, the rest of them. But, and they're measured through extent and then severity. Again, extent is how often it shows up, and severity is how bad it is. So in this case here, if you select for a longitudinal transverse cracking, medium, once you select that, you go to the next stream. This is behind that software. In the software, this basically comes down, and once you select that medium and that longitudinal transverse cracking, it'll bring you over to here. So you've got medium and medium. That'll recommend a repair category of crack repairs. And from within there is going to be your individual repair options. But at the same time, when you select that, over here, you're selecting a PCI deduction value. This deduction value in this case would be 6. So out of 100, 3 of the distresses are automatically deducting 2 points. So from that, based on the deduction system, we're starting out with the highest value of 94. That's a perfect road. So it's one between 1 and 94, but you're deducting all these values out of 100. And again, as I mentioned, the deduction values are right here. Here's an example how that's calculated. You've done your assessments and your deduction values for longitudinal cracks, transverse cracks. So you're deducting 12 out of that because you select that category that is pretty severe and it's deducting quite a bit of points. Edge cracking, you're losing 2. Bleeding, drainage, and roughness, they automatically deduct 2. But drainage seems to be a little bit worse. So you're deducting a little bit more. So you calculate that all up and you end up with a value of 23. You subtract that from 100 and you get a 77. Again, it's just a number, but it gives you an idea where that road stands within your network itself. This is the simple formula we were talking about. Looks pretty complex, but it's really basically pretty simple. And it does is it generates a priority. So you've got your repair category. Each one of those had a number. They were 1 through 6 that I had shown earlier. The importance, again, 1 through 5. Your collector roads are 5, your seasonal roads 1, and you've got your traffic volume on the heavier roads are going to be 5, and again, same with low on the lower ones, 1 on the lower ones. But it also takes into consideration the condition. We've got the PCI, which we just generated, and you divide that by 10. So in this case, we'd have a 7.7 for the value of C. And then with drainage and roughness, you're only evaluating severity. So it's good, medium, or poor. And as you go through, good is 1 deduction, 4 is 4, medium is 4, and then poor is 7 for both of those. And there's also a weighting factor where essentially you can adjust some of this. It's adjustable. You can put more emphasis on different categories to tailor your system to what you really want to focus on. So it's a pretty basic formula. Oop, let me just jump the screen. But on here, this is what the output goes. It develops a report, essentially, a readout report that gives you all your road segments. So across the top here, you've got your road identification number, your name, where it starts, where it ends, your mile point begin, and your actual length. In this case, it's miles. You've got your width in roads, feet, how many lanes it has, your surface type, shoulder type, the traffic, is it a very low one, a very high one? The importance of those, again, the importance of those roads. You've got the date when you've actually done it. The PCIs that are generated once you do those condition assessments and put that number in there, you'll generate a PCI number. It'll kick out a repair category within there, again, each of the repairs that you need to select to develop a budget. But it also kicks out the priority value. In this case, the higher the number, the sooner it ought to be done. If you'll notice down through some of these, the 102, the 102, 120, drainage work is very important. So it prioritizes that on the top. And then you get your crack repairs and your patching. So it kind of works its way down through there as far as the values, but it's greatly influenced as well by the traffic, the importance, and that repair category. And implementation, that is by far one of the more critical things that happens. You need to properly implement it and follow it up and keep it moving. It'll help you communicate with the board, but you need to communicate with the board what you're doing. And that'll really facilitate your implementation itself. It'll help you schedule work by prioritization and your PCI condition. And then part of that implementation is doing the update, that feedback, updating your costs, your unit costs, evaluating some of the maintenance techniques, seeing how they worked. If they don't work, maybe evaluating other ones, maybe considering some new techniques. So that's basically in a nutshell how it works. we've got now is basically a case study. We're going to have Chase jump in here. If you can help me out here, Adam. And Chase, if you can kick in when you get a chance.
Can you hear me now?
I can hear you.
Okay. Let me get this screen a little bit. Can you let me, I'm just going to share my screen the whole time if that's okay.
Sure.
Is it up? Can you see it?
Yep.
Good.
Okay, perfect. Okay, so basically what we have done is we have elaborated a little bit on David and Jeff's camp software, and we have added a GIS portion to ours. Basically, GIS is a geographic information system. So what we've done is, with the help of Esri, who is the maker of ArcMap, we have plotted over here on the side of the screen here. You'll see it's culverts, guide rail, pavement inventory, roadway maintenance. I'll kind of go through these a little bit, but those, if you will, those are all of our layers that we've plotted on the program. Now the GIS program is totally this what you're seeing is all web cloud-based. I also have the desktop version, but that's very complicated. That's more for getting it set up. This part here is very intuitive and easy to work with. So basically, if you don't know where Sherburne is, I will turn on my culverts and you'll see them pop up here almost in the middle of the state. And then I can zoom in. And if I log into, I can actually log into, I used to have Tim Hunt's password for town of Casanova, and I could make his pop up on here too. But so there we are, northern Shenango County. Get it back here in the middle of our screen. It will, the map, there it is. The map will come back. So there you have it. There's all of our culverts in the town of Sherburne. So what we've done basically is we had to get set up with this. I had my summer help go around town as they were weed eating signposts and stuff like that. They collected all this information using just their cell phones. And most of this has been done using cell phone. We now have a handheld GPS, which it was fairly reasonable. It was nothing elaborate. I don't know why my background's not up. It just shows blue here. But at any rate, all that does is get us a little bit more accuracy. You really don't need the accuracy if you're just mapping culverts and signs and things like that. So if I zoom in here, I don't know why it's doing that, but at any rate, what we can do, I'll just pick a culvert here. Here's a red one. So this tells us all of basically what I wanted to know about the culvert. A lot of this information we've gone back over and changed since, they did a pretty good job collecting the data, but it wasn't all perfect. But it tells us what it's made of, the condition, this one, that's why it's red, that it needs to be replaced. Diameter, length 40 foot, the road section that it's on, estimated replacement costs, those are probably a little bit old, those numbers now. Can the pipe be removed? This says no, do not remove pipe. We do have a lot of pipes that could be removed versus replaced and maybe redirect the water to another culvert that might also need to be replaced and not have to maintain two. So that's why I had that put in there. This is all totally customizable. So we can click out of that. And here, these purple, this app actually happens to be a bridge that we are replacing through a Bridge New York grant, but this has a little bit, I don't have a lot of information about the bridges because I don't do a lot with bridges, but that's what the purple squares are, the bridges that we have locally. So, and I can turn all of these on at one time or shut them off, but it gets really confusing when you start turning them all on. You can see down here, if I get down, you can see this road, this particular road here, this road here, this is where we have done a lot of culvert replacement. So you can tell by the average color of the dots in this area, we're in a lot better shape over here. So we need to get over here and work on some of these other roads now. So that's basically the culverts. Here, I'll show you the guide rail. Get that to pop up here. Oh, no, I'm sorry. Guide rail, we don't have a lot. That's a layer we're working on. We haven't collected. We do have a few on there. This is where we started. This layer here, this is our pavement inventory, which is a little hard to see, but it's all the black lines. We basically streamed all of those black lines by driving down the road. Try to make sure I don't have any questions here as we go. We drove down the road and just used the cell phone and streamed the lines onto the software. Roadway maintenance, let's talk about that one quick. So like I said, this background, it's hard to see, but these red stars here, those are potholes that I have gone around that I wanted filled. There's trees, you'll see the little trees here. This one here represents a sign, or wait a minute, no, that's a culvert. So these are things that, oh, here's the sign, the little flag. These are maintenance items that need to be addressed. So basically, as I'm out with my truck looking out, so that I don't forget, I'll just plot them on the map real quick. Then if I'm not around, I can tell the guys, look, go over such and such a road, cut these trees. They take our handheld GPS and they know exactly what tree I was looking at. Sometimes I also take pictures which can be attached to these. So when they pull it up, it'll actually show a picture of the tree that they should be cutting, because we all know how that could go. Under drains, we have been installing some under drains, and we plot those as well. That is one particular thing that you may want a GPS for, because the cell phone is just not accurate enough to go back and find the end of those if you want to clean them out. Here's our signs, they'll pop up. So basically we went through and we tried to make all of these represent what they are. We couldn't find a symbol for every sign out there, but we tried to get something close. Zoom in here a little bit. We did actually find a cattle crossing one on the program. They're not all on there, but any sign that's on there. Here's everything we wanted to know about our signs. It's vinyl. We do have old painted steel ones. This one's vinyl, steel post, southbound, placement good, heights good. Driver, we wanted to know, is the driver more than 8 inches above the ground? Does it need condition? That particular one needs replacing based on our criteria. There's a section for some notes, could be switched for a 4-way intersection. So really not the proper sign for the area. And that happens all the time. That's a warning sign, side road left. So that's every sign has that information. And believe it or not, it did not take that long to collect all this information. We have added quite a bit to it as we go. If my guys go out to replace a sign, they don't leave here without the GPS. They pretty much, I think they all can use it now. They'll go out and put the information right in, and as we change them. Let's read a question here. I'll try to answer. Once you have an inventory efficiencies that could be potential legal liabilities, that means that you will have to have a plan to address them, correct? Well, I mean, I think we all have a plan to answer that question. And I think we all have a plan. No, it does not mean you have to address them right now. You're basically just saying this is what we see. We do have a plan. We have a budgeted amount of money. We obviously can't fix every detail in town at once, and I don't think anybody expects us to do that. If it was something we thought was very severe, obviously we would. That is probably why you saw that other sign flagged on the roadway maintenance layer. If it's something like that, then we try to address it right then automatically. And like I said, the guys will go out and change it right on the handheld unit, and when they get back to the shop, it automatically updates. Now our handheld GPS, we could have cell service, and it would update automatically, but we don't. Whatever I do on my phone, which is an Android-based phone, and you're just using an app, it's the collector app. Whatever I do on the phone automatically updates right in the field. It's instant, but the handheld is not. But when they get back to Wi-Fi, it updates at the shop. That's what we have for layers. You may have other things that you want to see. You may have other features that you need to map. Water lines, hydrants, water shutoffs. If you're going to do that, you would probably definitely want a GPS unit to use to get more accuracy for water valves and like that. We don't have any of that, so we didn't have the need to map those. But those all can be added in here. The diameter of the pipe, you can do a line where the line runs. Well, so here is our parcels. This came from the county tax department. These are all the property parcels, which I've used quite a lot. If we get working on a road and I need to know who owns a certain piece of property, maybe we're doing something in front of their house, the name is on here. Usually can go back through and find out who that is. So that's been very handy. Watersheds, this is a pretty elaborate one that I had an intern work on, the same intern that did that set this up and did our pavement management program through David and Jeff. Also these are some of the area watersheds for particular larger diameter culverts. As let me zoom out here. We wanted to know how many acres roughly were going to a particular pipe. You can see up in this area this is a large portion of Brookfield state land that comes down through a particular pipe that we have. So we tried to map those drainage areas to help with culvert sizing. There's several other layers that you can get. You could actually get your pavement inventory, your road layer through the state. They I believe are completed with their GIS mapping of all the local roads. So you can get that layer. You can get flood zones. I do have a flood zone one, but that's really hard to look at. It's awful complicated. There's a lot of different things you can get from your county planning department. You can get, they use GIS, or at least they do here as well. So that's basically it. This is what I submitted for the build a better mousetrap competition. So we'll see how we do with it. And I think that's all I have right now. I don't know, Jeff, do you want to add anything to that?
No, I think it looks good. It's really made looking at what you have from an overview pretty easy. You were saying you also had something on your phone when you were at a conference. You could actually tell when people were doing things on the job.
Yeah. So, well, basically, so if I load the roadway maintenance layer is what we use for maintenance. So as my guys so say I go to highway school and there would be a lot more plotted on here if I was going away. But as they cut these trees or as they fix these potholes, they delete them off of the GPS unit. So at the end of the day, I can go back on here and I can see how many they've completed, where they're at with things, because these would no longer be here because it updates when they get back to Wi-Fi. So automatically it'll update and erase them right off the screen. So I can look at it live on my phone. So it's very intuitive. It's very simple to use. So and I can show you. I could show you. Let me shrink this over a little bit. I don't know if I can. Can I? If I can turn on the video, Adam, help me out here, buddy.
Your screen is shared, so anything you want on your
Video.
machine, you can do.
Well, it says my host has stopped it. But anyways, I could show you the handheld GPS that we do use. It's just a small Trimble unit that the guys use. Very durable. They've beat it around pretty good and it still holds up. I'll show it to you here quick.
There you go, Chase. You should be all set.
Yeah. So this is what we have, and I'll show in comparison. This is my smartphone. It's pretty much the same thing. It's just thicker. It has a bigger battery. You will find that's one of the only problems with collecting the data with a smartphone is it uses a ton of battery, which was another reason we picked this up. So this will go all day. Smartphone, couple hours, you're out of battery. Other than that, I mean, the app is available in Apple or Android. So regardless of what you use, you can download the app and start collecting data. So any questions? I don't see any questions. One question.
That's
No.
a leftover for Jeff, actually.
Oh, okay. Yeah, any questions, Dave or Jeff, or anything
Well,
else?
we'll see if people type things in.
Yeah.
Here's one for you.
Anything you'd like to see, just holler.
He says here, if a tree is removed, it disappears from the screen. Have you tied it to a reporting system?
Oh, no, not necessarily, but if you wanted to, what you could back this up daily, and then every time you back it up, you're going to have a recording of what was marked. You go back the next day and see how it's changed. So it'd be very easy to do. I don't do that. I don't have a need for that, but it wouldn't be hard to do. What device is used to collect data? Well, we started just using the smartphone. This is just my smartphone. We started using this. Actually, my summer help use their own phones. And they're generally, what 16 to 18-year-old kids. They're all pretty good with a phone. So you hand them a phone and say, collect me some information, they're going to do it. And they did a pretty good job. You know, we gave them a wheel to measure the length of the culverts, tape measure, and their phones, and a couple weed eaters, and they did a great job. But the other device we use now a lot of times is it's a Trimble. It's a TDC 100. There's several other ones that you could use. It doesn't have to be this one, but it's just small enough to throw in your back pocket and carry around. That's why we use that. And it's just a download an app, the collector app. It's you download it, and what you guys are looking at is this is ArcGIS online, cloud-based only. That's why it all updates automatic, you know, just if you have cell service, it updates. So I think that's it for questions. So that's that. I don't know. Hopefully it helps somebody out. If anybody wants information on any of this, reach out to me. I can share what I have. I don't know a ton about the desktop version. I have it on this computer, but it's very complicated. I can get on there and navigate it, but I don't build maps and things like that on there much. It's
Well, if
just,
people have questions, they can send them to us, and either we can help or send them on to you, Chase.
okay, sounds good.
All right, I'll jump screens now. Let's see, where am I? Oh, I gotta... Huh. Here we are. Maybe. There we are. All right, I figured it out all in 1 minute. All right. So at this point, aside from the benefits you've seen from Chase, having that right in your hand, being able to tell what's going on, other benefits basically of pavement management system would be the efficient use of limited resources. Now you know where to spend it. You have an understanding on what the costs are. You can be a little bit more cost effective in your decisions. Now you can substantiate your results because now you've got an objective opinion from what you're doing. It's not your opinion or what you think or your gut feel. You've actually got a documentation that says we should do this. So it really kind of substantiates your results. It helps you determine the conditions and what you've actually got. And again, that's going to help you understand where you're going and what you got and what you have at that time. It improves communication by having those substantiated results. Knowing what your conditions are, it's a lot easier to explain to somebody what you're doing, why you're doing, how you're doing it. Better communication with the board, better communication with the community. All of them want to know why you're putting a chip seal over a good road. Well, it's time. So it helps you better communicate that. Provides you more accurate information, obviously. If you've got all that information, it's going to be substantially more accurate. And because you've got all this information that's substantiated, documented, you know what the conditions are, you know your status in your network, you're going to get improved cooperation, not only from the community and the board, but if you're looking for grants, it's going to be a lot easier to justify why you need the money because you can say we need it here and we need it there. So having some sort of plan is going to go a long way. All right, Adam, we're going to do some PDH questions here now. So the question here, we've got what recommendations do you have for creating a formal adopted programmatic pavement maintenance plan? I guess it really depends on your system. If you're looking to go high tech, there are a lot of options out there, but if you're looking to do something simple, if you're interested in the Camp RS, that's available. If you need some sort of guidance, let me know. I could come out and do a site visit if they'll allow me. And kind of work through it with you. And we also have our summer intern program, which allows you get the municipalities and we match them with a student. And the intern, as in with Chase's case, went out and did all the legwork, gathered the inventory, did all the assessments, created a plan, and then wrote up a report basically explaining what they had done. And that was a valuable asset as well as far as providing to the board. And some of the towns have actually put some of these plans up on their websites. And when people call asking, why are you paving this road and not this road? You can send them right to that plan and say, well, this is our plan for the next 5 years. And a lot of times that'll satisfy them. So, all right. So we've got our questions.
They're answering them, Jeff.
Good.
There are, let me see, 4 questions.
Yes.
And we got about 22% voted, so we're going to wait for a few more folks to answer for you. It's anonymous, folks. There's no right or wrong answer. The first one is network level pavement management systems focus on the details of a project to develop a final plan, true or false? 2, a simple PMS process does not include easy to learn method, systematic and organized approach, practical method of prioritization,
Yeah, that's-
Prediction of future conditions. And then pavement management focuses on keeping good roads good, and fixing the worst problems first is the most efficient use of funding. And we'll get to at least 50, well, at least half the folks voting. You guys can do it. I know you can. And we promise we aren't recording this. I don't think we're that sophisticated.
I'm not.
Okay, here we go. We'll end the polling and share the results.
Uh-oh, it's gone.
I hit a button. I think Adam and I hit it at the same time. Okay, there you go.
No, a network level system basically focuses on the overall network with limited amount of information. Once you go to a project level, that's when you want to know where the details of the plans are. So that would be a false answer there. Simple pavement management's process. Again, simple is the key there. It doesn't predict futures. You get into really complicated software when you get in there. Yes, focusing on good roads good is the key. And fixing worst problems first is not the most efficient way. So most of you guys got those right. So these are our upcoming internet-based items here. We've got a bumper banter. If you'll note, it's on Tuesday. We've got a holiday on Monday. We've got David's got a webinar on Tuesday afternoon from 2 to 3 about work zones, keeping everyone safe in the work zone. And then again on Thursday, we've got another webinar 2 to 3 on budget basics.
Yeah, our two newest circuit riders, Guy James formerly from Allegheny County, and the aforementioned Tim Hunt from Cazenovia, are doing that particular webinar.
So they should be good. I'm looking forward to that. So I'd like to thank everybody, and if you've got any questions or anything, let us know. Contact us through Cornell or the CLRP email, or call us directly. All our information's on the web.
And there's no questions available for you, Jeff, so I think we're going to tell everybody, have yourself a good afternoon, and it's a blue sky, so get outside and enjoy.
All right. All right. We've got a little over, I guess, but it's,
Thanks very much, folks. Have a great day.